My name is SP Tobela. I'm a lecturer at Ehlanzeni TVET College, based at Mashishing campus. Today we'll be doing Engineering Systems NQF Level 2, of which we'll be focusing on the topic that says Basic Calculations in Mechanical Engineering System. First, I want us to check what do we mean by mechanical engineering system. We say mechanical engineering systems, we are referring to engineering systems that uses engineer or gears to transfer power. For example, we say it's a car. And also, we have varied output of mechanical engineering system. What are the varied output of mechanical engineering system? We are referring to mass, the weight, the force, the work done, the power, and the torque. Then now I want us to check the definition of what do we mean with this varied output mechanical engineering system. First, we'll look at the mass. We say, what is a mass? We say a mass is the amount of a matter in an object. The amount of matter in an object we refer to be a mass, of which we use symbol M for mass, and the SI unit is kilogram, or you can just say kg. And then now, I want us to look at the weight. What is weight? We say the weight of an object is the force of gravity. The weight of an object is the force of gravity. Then, of which our weight, we can be mathematically written as W is equals to M times G, where our M is the mass in kg, and our G, of which is our gravity or force of gravity, we say it's 9.81 meters squared per second. And then now, we want to look at the force. What do you mean by a force? We say a force is an influence that changes the motion of a body, or you can say a force, it's an influence that produces motion or stress. And it can be also mathematically expressed by saying F is equal to M times A, where our F, of course, is the force and is measured in newtons, and our M is the mass and also measured in kg, and then we have our A, of which is our acceleration and is measured in meters per second square. And then I'll also want us to look at the work done. What do you mean by work done? We say a work done is whenever a force moves along or acts all the time on an object to display it. That's what we mean by a work done, of which we say a work done can be expressed as W is equal to F times S. And then where we say our W is the work done, which is measured in joules. The F is the force, which is measured in newtons. The S, we're referring to the distance, which is also measured in meters. And then I would like us to check the power. And then we say a power is the rate of doing work or transfer energy. The rate of doing work or transfer energy, we refer it to be a power. And power, of which is P, is equals to W over T, of which our W is the work done, measured in joules, and our P, of which is the power, it's measured in watts. The T is the time measured in seconds. Therefore, we say work done or energy transferred in joules can also be referred to be the power multiplied by the time. Then now I want us to look at the torque. We say the torque is the turning moment produced by a force. A torque is produced by a force, of which you say we can be able to calculate by multiplying the force rotating the object with a perpendicular radius through which the force acts, of which you say the T is for torque, F is for force, multiplied by R, of which you say it's a radius. And then you also know that the torque must be measured in newtons per meter, because the force is measured in newtons, the perpendicular radius is measured in meters, and the force multiplied by a radius, then it will be the newtons per meter. Therefore, since we have already discussed the varied output of mechanical system, I want us to look at the calculation. Let us apply the mechanical engineering system. Let us apply. So we say mechanical engineering calculation. Going to look at the mechanical engineering calculation. Then let's check from a given statement, of which is number 1, of which it will be our example 1 for today. It says, calculate the force that is required to accelerate a car with a mass of 2,000 kg at 5 meters per square second. So we say we are supposed to calculate the force. This will be our data. Our force is the unknown, or our force is what we're looking for, and we are given our mass, of which it's m, to be equal to 2,000 kg. And then we are also given our acceleration, of which it's 5 meters per second square. Therefore, since we are given the m, of which is the mass, a, of which is the acceleration, and we know that if you want to calculate the force, you simply say your F is given by your mass multiplied by your acceleration. And therefore, our mass is 2,000. Our acceleration we're given as 5. Therefore, 2,000 multiplied by 5, say 2,000 multiplied by 5. Therefore, you get 10,000 newtons, of which newtons is the SI unit of a force. So I hope we understand and we are following from where we were extracting our data and where we did our actual calculation. So then, I want us now to look at number 2. Then we are given number 2, of which it will be example 2. Example 2. Example 2. Example 2 says, calculate the work done in joules when raising 100 kg of water through a vertical pipe with a distance of 3 meters. So if you look from our example 2, they say we're supposed to calculate the work done. Okay, if you look for example 2, and you check the data given, you say we are given the mass. We're given the mass as 100 kg. We're also given the distance of which is used symbol S for distance as 3 meters. But we are required to calculate the work done. We are required to calculate the work done. So how are we going to do? So how are we going to go about our calculation? We simply say, since we're looking for our work done, of which we know that work done is the force multiplied by the distance. And then now, we're not given a force from our statement, but we're given a mass. And then you know that a force is given by a mass times gravity. The mass times gravity. So your M, of which is your mass, it's 100. 100 times your gravity, of which is always constant, is 9.8. So 100, if you say 100 times 9.8 from your calculator, you'll get 980 newtons. But remember, the question was saying calculate the work done. So now you have your force, so you can simply go and substitute from the formula, of which the actual formula for the work done, we say it's W equals to force times S, of which is the symbol for a distance. So now you can simply say, now you can simply say W equals to F times distance is the same as 980, of which is the force, and the distance, of which we are given as 3. Therefore, 980 multiplied by 3, we are given as 2940 joules. I hope you are following, and now you understand how to calculate the force and also how to calculate the work done. So now I want us to continue and look at number 3 and look at example given, of which is number 3, of which it will be our last example for this lesson. So example 3, number 3 says, calculate the torque exerted on a spanner if a force of 45 newtons is applied to the spanner end, and the spanner is 20 centimeters long. So, our given data, if we check from our example 3, we're given data. We are given a force of which is 45 newtons. Force of which is 45 newtons. We are also given a spanner of which it says is 20 centimeters long. The spanner is 20 centimeters. 20 centimeters long, of which this is the distance of the spanner. But then the question says, calculate the torque. You're supposed to calculate the torque. You're supposed to calculate the torque. So now you know that from the formula to calculate a torque, we say it's force multiplied by R, of which the F is a force, the R is the perpendicular radius. So from the statement they say the spanner is 20 centimeters long. That is why I said the 20 centimeters is a distance. So now we have to we must first convert the centimeters to meters. Remember, a torque is measured in newtons per meter. So you say D of which is 20 centimeter. And we know that 1 meter is given by 100 centimeter. So now, since we have 20 centimeters, which means we will say D is equals to 20 divided by 100. We say 20 divided by 100. So if you say 20 divided by 100, it's given, the diameter is given as 0.2 meters. But remember, from the formula we say, to calculate a torque, we say a force times a radius. A force times a radius. So now, since we have the distance of which is 0.2, therefore, you'll say the radius of the distance, it's R, is equal to 0.2 divided by 2. 0.2, you say 0.2 divided by 2. So if you work out from your calculator, you will get 0.1 meter. 0.1 meter. So now you can be able to calculate the torque. So you'll say, therefore, the torque is given by force times the perpendicular radius. And your F, you're given as 45 newtons. So you'll say 45 times the radius. We have calculated the radius, of which is 0.1. So it's 45 times 0.1. So what will be 45 times 0.1? We say 45 times 0.1, and we'll get 4.5, which means it's 4.5 newtons meter. The torque is 4.5 newtons meter. So I hope now we understand, now we are able to calculate the torque. And remember, we firstly calculated the force, and number 2, we calculated the work done, and now number 3, we're calculating the torque. So now let's see example 4. Then our example 4 says, work out the power in a 12-volt windscreen washer pump motor when the motor uses 4 amps. Then they say we must work out the power. So we first will check on our given data. What is it that we are given? And what is it that we are looking for? You say our given data, we are given 12 volts, of which 2 power V, or the voltage, it's 12 volts. And we are also given our current as 4 amps. So we're also given our current 4 amps. And we are required to calculate the power. We are required to calculate power. But then we know that the formula to calculate power is given by P is equals to I multiplied by V, of which is the current multiplied by the voltage. So now, since we already have our current, of which we were given from the statement, we're going to substitute I by 4. And since we're already given the voltage from our statement, we're going to substitute V by 12. Therefore, we say 4 times 12, of which you get 48 watts. Remember, power is measured in watts. So power is 48 watts. So now, since we have already calculated number 4, of which is our power, we are going to look at the last example for today. If you check from the statement, it says how much energy is used by a starter motor that uses 150 amps at 10 volts for 6 seconds. For 6 seconds. Therefore, our given data from the statement, we are given our current is 150 amps. We are given our voltage as 10 volts. Our voltage is 10 volts. We are also given the time as 6 seconds. So our T, we are given as 6 seconds. And then you are requested to calculate the energy that is being used by the starter motor. So the energy that is being used, you know that energy is the same as the work done. So now, if you want to calculate the energy or the work done, you'll simply say, we know that's our W for the energy is given by the power times time. But then if you can check from our given data, you are not given power. But then since we are given the value of I, of which is 150, also given the value of V, of which is 10 volts, we can be able to calculate the power. So we'll say P is given by volt times I. And then we'll say our V we are given as 10 multiplied by the current we are given as 150. So 10 times our 150, you'll get 1,500 watts. But remember, the question was saying calculate the energy used. But now, since we have the value of a power, we'll say, simply say, therefore, you'll simply say, therefore, the energy used is the power times time. So which power we given as 1,500 watts, and we say our P is 1,500 watts, and our time we are given as 6 seconds. 6 seconds. Therefore, we're going to say 1,500, of which is our power, multiplied by the time, and then we're going to get 9,000 joules. Remember, we are calculating the energy and it's measured in joules. So I hope you enjoyed the lesson. I believe that now we are able to calculate the force, the work done, the torque, the power, and the energy. So if you have any question regarding this calculation, you are free to contact us at our website, of which is ehlanzenicollege.co.za. You can also contact us on our social media platforms, of which on Facebook, it's Ehlanzeni TVET College. On our Twitter, it's @Ehlanzeni TVET. On our YouTube, it's Ehlanzeni TVET College. Thank you.